Okay, this video is about how to find a vertical asymptote from a rational function equation. So this equation has already been written in standard form, and we can see that we would have two values that when you evaluate, you would be undefined. So if you were to plug in -2, x not equal -2, you would have 0 over 0, that's undefined. We already know that that gives us a hole on the graph. So because this simplifies to make a giant 1, it has almost no effect on the graph, it creates a hole. Today's question is what happens with this other value that we can't plug in? What's going on around x equals 3? And to see what's going on, we know we cannot plug in 3. So what we'll do is that would be undefined. We'll see what happens as we get close to 3. So if we were to plug in 2.5, if we were to plug in 2.8, if we were to plug in 2.9, if we were to plug in, and just keep going. And we can see that these numbers are just getting bigger and bigger and bigger as we get closer and closer to 3. It turns out that this is going to go on forever. So if we were going to use our notation here, we would say as x is getting closer to 3, our function on this side is actually moving towards -infinity. So this is getting closer to 3 from the left. We'll look in a second what happens as we move closer and closer from the right. So we're moving here down towards -infinity. What if we approached it from the other direction? So what if we went with numbers that were just a little bit bigger than 3, like 3.1, 3.01, 3.001? You can see the opposite is happening. Instead of the numbers getting more towards -infinity, they're getting bigger and bigger and bigger, and they're actually moving towards +infinity. So when we are moving towards 3 from the other side, we are actually moving towards -infinity. I mean, +infinity. Okay, so that means that the graph is going to be moving up like this. Now, what does that mean that the graph looks like? That means that there is actually a vertical asymptote when x equals to 3. So remember, we had that restricted value from this factor right here. X cannot equal 3. There is a vertical asymptote x equals 3. I'll show you what that looks like in our graph right now. So here is a picture of the graph of this function. And if we were to type x equals 3, I'll just change this to be a dashed orange line. You can see that there is a vertical asymptote. As we move towards that dashed line, the function is getting closer and closer and closer to the dashed line. It will always be moving towards it. No matter how close we get to 3, the function